Hello, everybody. Hopefully all is well. This is Dr. Looney coming with another video. This video that we're doing today is basically over analyzing graphs. Basically, you can analyze a graph from the first derivative, second derivative, and then the last thing we'll talk about is points of inflection. So let's look at this graph. I just labeled this the graph of f, and y is equal to f of x. And it says determine where the derivative, the first derivative is greater than 0. So where is the first derivative positive? And then it says determine where the second derivative is greater than 0. And so when we're talking about the second derivative being positive, that just means we're trying to find out where does the graph of f concave up. So let's look here. Well, first of all, if the first derivative is positive, then that means the function is going to be increasing. So we can see that the function is only increasing. We can just say this number right here is 4 from 4 to 5. And so now we just need to make sure that the graph is concaving up from 4 to 5, because if it's not concaving up from 4 to 5, then there's not going to be any solution to this. So if you can see here, the graph is actually concaving up from 3 to 5. So since it's concaving up from 3 to 5, we know that it's concaving up from 4 to 5. So that will be the answer. We can see that for my x values that are between, I put 3 here, but I meant 4. Yeah, so for my x values between 4 and 5, we know what that f is going to be increasing, and this is because my f prime is greater than 0, and then we also know that f is going to concave up because my f double prime is greater than 0. And so that is going to be the answer. This is not a formal way of writing this up if this was a free response question, but just for time's sake, that is how I'm going to write it up today. The question that you will have on the quiz that is similar to this one is multiple choice. So, but this wouldn't be proper justification if this was a free response question. All right, so let's look at the next example. So in this example, we're going to do something different. We're going to compare f of 5 to f prime of 5 and to f double prime of 5. So we want to see what the relationship between those three values are going to be. So let's go ahead and do the easiest one. Now, this is a graph y is equal to f of x, and this just says it's twice differentiable. So that just means you can't take the second derivative. So we do know that f double prime of 5 is going to exist. All right, so if we look at f of 5, well, f of 5 is just this point right here. So that's going to be an x-intercept. So we know that that value is just going to be equal to 0. Now let's look at f double prime of 5. Well, look at the function f. This function is always going to be decreasing. So since the function is always decreasing, that means that f prime of 5 is going to be less than 0. And then if we can see here, well, how do we determine what f double prime of 5 is going to be? Well, we'll look at the concavity of the graph, and we can see here that this graph is going to be concaving up. So we know that f double prime of 5 is going to be greater than 0. So the smallest of these values is going to be the -1. So I know that f prime of 5 is going to be less than f of 5, which is 0. and any positive number is going to be greater than 0. So I know that f of 5 has to be less than f double prime of 5. So that is the relationship between the value f of 5, f prime of 5, and f double prime of 5. Alrighty, and then our last example is going to be talking about the point of inflection here. So we want to find the point of inflection, and luckily we have the second derivative already given to us, because if we didn't have the second derivative, we would have to, if they've given us the function of f, we would have to take the derivative twice. So they've given us the points of inflection, not the points of inflection, but the second derivative. So in order to find the points of inflection, we just need to find where the concavity is changing. And so that's basically what the point of inflection is. It's just telling us where the concavity is going to change. Now, what is concavity? If I have the second derivative, concavity is where the second derivative either changes from positive to negative or negative to positive. So if you have your numbers can have three be put in three categories. So either a number is going to be positive, a number is going to be negative, or the number is just going to be 0. So if we find out where the second derivative is 0, everywhere else it has to be positive or negative. So we can see here that the second derivative is going to be when x is equal to 0, when x is equal to -3, and when x is equal to +1. You basically just set each one of these equal to 0 and solve for x. And I'm not going to go through that because I'm sure you guys know how to do that. And so now we have our possible candidates for points of inflection. So let's go ahead and test values to the left and the right of that. So I'm going to test values to the left and the right of -3, 0, and 1. So for -3, you can see that I've already did the work here. And so but I'm just going to tell you the numbers that I use. And so we'll go from there. So I'm going to choose -4 to the left of -3. Now here I don't have to plug in anything because this is a square. So I know this is always going to be positive. And if I put in a -4 into here, well, that's just going to give me a negative number because -3 plus, I'm sorry, -4 plus 3 is -1. And then a negative minus a negative is also a negative. So I have positive, negative, negative, and a negative times a negative is positive. So, and a positive times a positive is positive. So this does work out. This is positive. And then next, we're going to choose a number between -3 and 0. I chose -1. And again, this is always positive, so I don't have to change that. And then if I put a -1 in here, well, a -1 plus 3 is going to be a positive number, so that's positive. But a negative and a negative is going to be a negative number, so this is going to be negative. So a negative times a positive is just going to be negative. All right, then let's choose a number between 0 and 1. I chose 1/2. Again, this is always positive. I'll put a positive number in here. Well, a positive number plus 3 is still positive, so this is positive. But here we're going to get 1/2 minus 1, so that's going to be negative. And so we have, again, a positive times a negative, which is going to be a negative. And then lastly, I chose the number 2. So again, this is positive always. If I plug a positive number, or a positive number plus 3 is still positive. But this time we get 2 minus 1, which is a positive number. So we have a positive times a positive times a positive. So that's going to give me a positive. So as you can see here, from -infinity to -3, the graph of f is concaving up. But then you can see that the concavity changes from positive, that it changes from concaving up to concaving down. So I know that when x is equal to 3, this is going to be a value where the graph has a point of inflection. Here we're staying, we don't change concavity, so it keeps concaving down. So 0 is not going to be a place where we have a point of inflection, and then here we go from concaving down to up. So 1 is going to be a point of concavity. Well, when the value of x is equal to 1, we know that that's going to be a place where the graph is going to change concavity. And so the question is, find the value of x when f has an inflection point, and those values are just going to be when x is equal to -3 and when x is equal to +1. Hopefully this video helped you guys out a lot. If you have any questions, please just email me. There is always a quiz that is going to be associated with the video lessons. If you do not find the quiz under assignments, you need to click on the quiz tab to find the quiz. Don't ever assume that there's not a quiz because you don't see it in the assignments tab. That just means that it's located somewhere else that you're going to have to look for and find. If you can't find it, ask me questions. But please don't assume that I'm not giving you quizzes weekly, because I am. All right, again, hopefully all is well. That's the end of the video. You guys have a good week.